In this video, we're going to look at simplifying algebraic fractions by cancelling. Now, the first thing we need to understand is we need to understand what this word cancelling is and how do we cancel within a fraction. Now, let's start off with simplifying a very straightforward fraction like something like 2 over 10. If you were to do this, we probably wouldn't do this by cancelling, we would do this by recognising that both of these are in the 2 times table, and what we would do is we would divide by 2 and we'd divide by 2. And that would give me 2 divided by 2 is 1, and 10 divided by 2 is 5, and that would simplify down to that. Now, what we're going to look at next is we're going to look at an algebraic example. So say, for instance, I had A times B times C at the top, and A times E times F at the bottom. Now, what people generally see when they think about the word cancelling is cancelling out or scoring out things which are the same at the top and the bottom. So if I look at the top here, I've got A, B, C, and the bottom I've got A, E, F. So what they both have in common is A. So A and A can be cancelled out. Now, that would leave me with, I would check there's not a B at the top and the bottom, there's not a C at the top and the bottom, neither is there an E or an F at both top and bottom. So I can then write out what's left, and that would equal BC over EF. Now, what's actually happening there is not just a case of some sort of magic trick cancelling something off the top and the bottom and they disappear. What we're actually doing is we're doing the same as what we've done up here. We're actually dividing the top and the bottom by something, and the cancelling out is just a way to show that. So what I'm going to do is I'm going to rewrite this and show you what's actually happening. So if we look at the ABC over AEF, again, what they both have in common is A and A. Now, when we simplified this basic fraction, we recognised that both of these were divisible by 2, so we divided by 2 and divided by 2. What we're actually doing here as well is we're actually recognising both of these expressions, ABC and AEF, they're both divisible by A. So what I'm doing really here is I'm actually dividing by A and dividing by A. Now, when I divide A by A, if you think about it, A divided by A is just equal to 1. Anything divided by itself will be 1. So what will happen here is this A here divided by this A here will give me a 1, which means that will turn into a 1, and it'll be BC. So I'll be left with just 1 BC. On the bottom, this A here can be divided by this A here. So A divided by A is 1, so that leaves me with 1 EF, which I can write at the bottom. Now, I wouldn't normally write these ones, so we could get rid of them and they could disappear, but sometimes it's important to understand that when we do cancel, it does actually leave behind a little one like this. So I would just write this as BC over EF. And as we go through the examples in this chapter, we have to remember that. We have to remember that cancelling is not just a case of scoring out from top and bottom. What we're actually doing is we're dividing by that value on the top and the bottom. And when I divide something by itself, it always leaves behind a little 1. And if you remember that, it'll make the rest a lot easier. So we're going to look at some examples of algebraic fractions and try and use this cancelling method, which remember is just division by the same amount at the top and the bottom, to solve these few problems here. So let's start off with this first one. When we see 3xy over 6x squared, what we need to think about that as is we need to kind of think about it as 3 multiplied by x multiplied by y. And on the bottom, when I've got this 6x squared, we need to think about that as 6 multiplied by x multiplied by x again, and that's my x squared. Now, what we're doing here is, remember, we are trying to cancel out top and bottom. So first thing we need to do is we need to look at the numerical part. So I've got a 3 and a 6. We already know how to simplify 3 over 6. So both these are in the 3 times table. So I can divide them both by 3. So that's going to leave me with a 1 there and a 2 there. In other words, 3/6 we know simplifies down to 1 over 2. And then we can start to cancel here. Now, that and that will cancel because we've got an x and an x. And it will leave behind little 1s. Okay, and then over here, I've got a y and an x, which aren't the same, so I can't cancel. So what I'm left with is 1 times y. So that's going to be equal to y at the top. And at the bottom, I've got 2 times 1 times x, which is going to leave me just 2x at the bottom. And then that is it fully simplified down. Again, remember what you're doing here. It's not just a case of cancelling and scoring things out. We are actually dividing the top by x and dividing the bottom by x to turn these into 1s. And we are dividing the top by 3 and the bottom by 3 to get our 1 and our 2 here. So while we will just cancel and leave behind these 1s, we need to remember what we're actually doing here to help us occasionally. So let's have a look at the next example here. we've got 4u squared v and 2uv squared. So let's write that out. The way we would think about that in full is that would be 4u squared v is 4 multiplied by u multiplied by another u multiplied by v. And on the bottom, we have 2 multiplied by u multiplied by v squared, which is times v. Okay, so when I want to cancel here, again, I'm going to start off by looking at the numerical values, 4 and 2 here. So again, that can be simplified. So both of these are in the 2 times table, so divide them both by 2, and that will simplify down to 2 over 1. What we can then start doing is this division of top and bottom by the same amount. So we're dividing top and bottom by u, which remember results in us just being able to cancel them. When we cancel them, they'll leave behind these little ones. And then we've got a u and a v which don't match, and a u and another v which don't match. But this last v here, it can be cancelled out with one of these v's on the bottom. So I'm going to just do that quickly. Dividing top and bottom by v gives me this, and this will cancel to 1s. And then what I'm left with, I can then go through and just quickly check. Now, what I've got is 2 times 1 times u times 1, which is just 2 times u. So that's 2u here. And on the bottom, I've got 1 times 1 times 1 times v, which would just leave me with v here. Now, what we don't want to have to end up doing is we don't want to have to write out this sort of like full version every single time. Now, I'm going to do it just for this particular example. And as you can see, it ends up looking quite horrible. So bear in mind, what I could do is I could go through these and cancel and leave 1s, but a better approach here might be to just think about this as, well, let's start off with the 4 and the 2. So the 4 and the 2 at the very start of this, we know that's going to simplify down to 2 over 1. So I'm going to just put the 2 and the 1 there. I'm dividing that by 2 and I'm dividing that by 2. Then the next part might be a good idea just to consider the x's on their own. So if I only consider the x's, I've got x to the 5 at the top, which we know from here, and I've got x squared at the bottom, which I know from here. So if I think about where are there more x's multiplying each other, top or bottom, and I can see there's more multiplying each other at the top here. And the next question I want to ask myself is how many more? So how many more is 5 than 2? Well, it's 3 more. That will tell me, because I've got this 3 extra x's at the top, when I cancel these, that's what I'll be left with. So there's more at the top, and there's 3 more multiplying each other at the top. So what that's going to leave me with at the top is x to the power of 3, the 3 that are left over. Similar question, where are there more y's multiplying each other, top or bottom? Now from this we can see there's clearly more multiplying each other at the bottom here. And again, how many more? Well, 9 is 7 more than 2. So when I cancel, I'm going to have these 7 extra y's here left over. So because there's 7 more at the bottom than there's at the top, the ones that I cancel here and here and here and here, there'll be that 7 extra left over, which won't cancel with everything. So what we can do then is we can put y to the 7 down here at the bottom. And then again, we've got our z's. Where is there more? Well, there is only one z, so it doesn't have anything to cancel with. It's currently at the bottom, so it's going to remain there at the bottom. Now, the only thing I would tidy this up with is I would get rid of that 1 at the bottom, because that just doesn't need to be there. So it's 2x cubed over y to the 7 times z. So there's a couple of questions I want you to think about when you're doing these is, where are there more, top or bottom? How many more? And that'll tell you whether to put that at the top or the bottom, and the number that goes as your index. We'll try a few more of these. So let's try 3 of these examples quickly. We've got here 6 over 3, so let's start with that. 6 over 3 would simplify down to 2 over 1. And then we're going to ask ourselves the same questions. Where are there more a's multiplying each other, top or bottom? There are more on the bottom multiplying. And how many more? Well, 5 is 2 more than 3, so there will be 2 left at the bottom. So that's a squared be left at the bottom. Where are there more b's multiplying each other? Well, there's more at the top, 7, and then we have a little hidden 1 here. So how many more? Well, I've got 7 and 1, so I've got 6 more multiplying each other at the top. So b to the power of 6 will be left at the top. And then that's it, fully simplified. The only thing I wouldn't leave here is I wouldn't leave this 1. So that 1 can disappear because 1a squared is just a squared. So I'm going to rewrite that as 2b to the 6 over a squared. We'll now have a quick look at the next one. So there's no numbers, so we've got c to the 5 and c cubed. Where are there more c's multiplying each other? Well, definitely at the top there. 5 is more than 3, so I'm going to be left with c's at the top. How many more? Well, there's 5 multiplying each other here, 3 multiplying each other here, so when I cancel, I'm going to be left with 2. there are 2 more at the top, so that's c squared. For here, d to the 6 over d to the 3, where are there more top or bottom? There's more at the top. And how many more? Well, there's 3 more at the top, so that's d to the power of 3 will be left at the top. And then here we have just e. There's no e down at the bottom here, so we can just leave that as it is, and that's going to leave me with e. Now, because I've cancelled everything off the bottom, remember that would leave behind a little 1, but we don't need to write that. So when you cancel everything off the bottom of a fraction, the fraction actually just disappears. We don't need to have it as a fraction anymore. So that answer there would just be c squared d cubed over e. The next one we've got here are 2 over 12, which we can simplify to 1 over 6. And then we're going to do the same thing. Where are there more top or bottom? Well, there's more on the bottom. So that's f at the bottom, and there are 2 more, so f squared. For the g's, where are there more top or bottom? And you can see here there are 5 more at the bottom, so g to the 5 is going to go at the bottom. And again, h's, where are there more top or bottom? That's got an h to the power of 1, there's a little hidden 1 there. So again, there's more at the bottom multiplying each other, and there are 8 more multiplying each other at the bottom, so we'll be left with an h to the 8 at the bottom. And then I squared, I've only got one of them, there's none of them at the top, so that's just going to remain as I squared on the bottom. Now, the important thing here is that that 1 is left. Because I've effectively cancelled everything off the top, remember each of these leaves a little 1. So 1 times 1 times 1 times 1 would just leave me with this 1 at the top. So when you cancel everything off the top of a fraction, remember it does leave behind a little 1. When you cancel everything off the bottom of a fraction, remember the fraction no longer needs to be there, it can be just written as a single line. I'm now going to get you to pause the video and try these 2 questions yourself. Once you've tried them, after each one you can press play and see if you've got them right. Okay, we'll look at example A first. So starting off with 2 over 6, well 2 over 6 both in the 2 times table, so divide them both by 2 and that leaves me with a 1 over 3. Next part is to look at the x's. They've got x to the 5 at the top, x cubed at the bottom, so when I cancel there are 2 more x's multiplying each other at the top, so that's what will be left behind, so that's going to be x squared left at the top. And for the b's, these are exactly the same, so this will just cancel with this, so the b's will disappear altogether. The only thing I would change here is I wouldn't leave this 1 lying around, so that's just going to be x squared over 3. For part B, we're going to start off with our 15 over 5, both obviously in the 5 times table, so they can both be divided by 5. So we're going to have our fraction, we're going to have 3 at the top, we're going to divide 15 by 5 and 1 at the bottom. We've then got x to the 8 over x. There are 7 more x's multiplying each other at the top, so that's going to leave me with x to the 7 when I cancel. And there are 2 more y's multiplying each other at the bottom than at the top. Remember there's a little hidden 1 here, so it's y to the 1 compared to y cubed. So I've got 3 here and 1 here. So that's going to leave me with y squared when I cancel that out. So y squared on the bottom. And again, the only thing I would change there is I would rewrite that as 3x to the 7 over y squared.